Welcome, everyone. Thank you very much for tuning in to a talk on driving DevSecOps diagnosis using Sumo's Global Intelligence Service as part of the DevOps track. My name is Shri Subramanian. I'm a product manager here at Sumo Logic, and with me, I have a couple of my colleagues from the Global Intelligence Service, namely David and Manpreet. So as part of today's talk, we will be covering key DevSecOps trends and the data signals identified from Sumo's Global Intelligence Service and how it can help you monitor, diagnose, and troubleshoot your cloud workloads. As part of the format of the discussion, it'll be quite interactive between me and a couple of speakers. I'll review some of the key learnings we've identified from our data, and then I'll bring in David and Manpreet to talk about how we could actually apply this data towards our daily practices. So the goal for today's session is helping you as practitioners who are running apps in the cloud to diagnose operational and security incidents using global cross-customer baselines. So what we have found is that as customers continue to adopt more cloud services, they are inundated with volumes of machine data that is hard to analyze and observe. To help with this analysis paralysis, we want to surface some of the best practices, commonalities, and outliers in our DevSecOps trends that could help us contextualize this data that we get from our own applications and guide us in making those right decisions. So there are three broad areas that we will cover. And for each of them, I will highlight some of the data that we have found and bring in my colleagues on how they would use this data during their day-to-day roles. So in terms of three things we'll cover, one, we will analyze and review how reliable are our AWS services and learn how to architect and diagnose your apps around some of these AWS-related root causes for outage. Two, we will analyze the relationship between an enterprise's attack surface and the use of AWS services, and will then discuss the implications of what it means from the perspective of what monitoring tools you would need. And then finally, we'll kind of review data on security threat events in AWS and discuss how to use this data to help prioritize threats. So before we proceed, just a small quick note about our Global Intelligence Service, or GIS. So GIS is a product area within Sumo Logic where we analyze data at scale across the entire install base and surface these as trends and baselines, allowing enterprises to benchmark themselves and gain insight into the AWS configurations. All the data we collect and analyze is stripped of all PII metadata and aggregate and analyze at scale, so it's completely confidential and anonymous. So the first item we will kick off with is on reviewing AWS-related root causes for outage. So an outage is one of the last things we need, and as part of the diagnosis, we will want to remove AWS as a factor for an app outage. There are broadly three kinds of errors for an AWS-related outage, namely availability, throttling errors, and insufficient capacity or out-of-stock errors. So starting with availability, building reliable apps and services on AWS requires reliable AWS infrastructure. How reliable are AWS services? If AWS is itself experiencing errors, it is important to factor that into the reliability of applications by adding error resilience. So what we did was, for the period from May to August 2020, we tabulated the service availability errors by region and programmatic API for key compute, networking, storage, database, and analytics AWS services. And the results show that while EC2 and ELB have high error rates, even these services are able to achieve 3 nines availability, which in this analysis translates to fewer than 1,000 errors per 1 million API requests to these services, in all regions except for US East 1. All other services profile achieve greater 3 nines availability in all regions. And among regions other than US East 1, all other AWS regions deliver at least 3 nines of availability for all services. So I'm going to quickly cover throttling and insufficient capacity errors next before coming back to analyze this in detail. So for AWS service, throttling errors represent scenarios where customers' requests are rate limited to ensure fair usage in a multi-tenant AWS environment. Throttling can be problematic for modern apps that scale out on demand, as these errors may occur during peak application demand. AWS Lambda, Elasticache, and Redshift were able to deliver 3 nines or better success rates in all regions, which translates to about 1,000 or fewer throttling errors per 1 million API requests to these services. So if architecture and cost permit, for any given AWS service, customers should attempt to provision adequate capacity, follow AWS best practices to mitigate these kind of effects of throttling. For example, things like exponential backup retries. The last type of error we see is around insufficient capacity, or also called out-of-stock errors. For AWS services, these errors represent scenarios where customers request EC2 instances of a particular machine type in a region, but AWS is unable to fulfill it. If these errors occur as your workloads attempt to scale out in response to demand, it's possible for your applications to experience slowness or become unavailable. With few exceptions, AWS regions are unable to achieve even 2 nines reliability for out-of-stock errors. So it seems to me here that the only viable solution for mission-critical workloads is to redesign applications to anticipate such errors and provision additional capacity ahead of demand. So in the larger context, let me bring in David here. When we look at availability, throttling, and insufficient capacity errors for AWS services, David, how should we really interpret this information when thinking about our own apps?
So thanks, Shri. So the way that you'll actually kind of get this information within the Sumo Logic application is via these GIS apps. And so what we're looking at right now is a screenshot from the GIS CloudTrail DevOps app that is giving you some information about these availability errors that Shri had previously described. So in these example dashboard panels, you see how many errors that you yourself are getting in your own app and infrastructure, with an overlay showing some statistics about the global benchmark rates that we're seeing for all of the other customers. And this information is meant to kind of provide a richer context through which you can interpret and understand your own error rates and kind of help inform two possible courses of action. So in the immediate situation, say that you're having an outage or some kind of operational issue, this can help verify that the error rates you are seeing are indeed elevated above the baseline, and this is something unusual. And that can kind of help you localize whether your operational problems can be kind of linked back potentially to some of these AWS related errors. If that is the case, it might sort of influence your choices of the next steps for remediating that issue. For example, if you have some worker process that is strictly dependent upon AWS service availability to perform its role, you might want to operationally sort of pause in queuing of new jobs for that worker process to avoid kind of further queue buildup. So one other kind of track is that you might want to think about this information from sort of an architecture and design perspective. So if you need to start backwards, you start from your SLOs of what you're trying to achieve with your app or your microservice, look at your SLOs for availability and latency and things like that and work backwards. If you have some targets for how available or kind of performance you want to get out of your microservice and you're dependent on these services, it would definitely be a great idea to take a look at these global benchmarks of error rates and things like that for those services. And that might kind of influence some of your design decisions. Then, like Shri said, there's sort of some classic kind of standard best practices like using the retry with exponential backoff from the AWS SDK, things like that. And at a more macro level, it might influence your thinking about how to set up cross AZ decisions for your services, or whether to pre-provision versus on-demand for different pieces, or whether you want to kind of diversify a little bit how you kind of fulfill given requests from a user, like having fallback mechanisms and things like that. So, has one kind of final suggestion for all of this is if you do see that you're experiencing sort of elevated rates above the global baseline, one possibility is that your usage of the service itself has changed due to a code push. And this is sort of outside the scope of this talk, but you can search in the Sumo Logic docs that you could use potentially log compare or some of the other operators and queries to examine your own calls into that service and see if a code push has kind of changed how you're using it. Back to you, Shri.
Awesome. Thanks, David. That was super helpful context here. So next from the Global Intelligence Service, we looked into usage characteristics of customers that use Sumo Logic to monitor the Kubernetes environment. So what we've generally heard from our customers is that it is difficult to find reliable information about how exactly companies are using technologies at the implementation level, all the way down to the configurations and the performance characteristics, etc. And what we've also found is that when an enterprise wants to explore architecture and evaluate options, it is very difficult to find broad overviews of industry trends based on real-time data rather than surveys or guesswork. This is especially true for a fast-evolving technology such as Kubernetes. So what we provide here are global baselines on how enterprises choose to deploy their applications on Kubernetes. From a cluster size perspective, the majority of customers are using 1 to 2 clusters to run their workload, with a steep drop once you go beyond 5 clusters. Similarly, from a deployment perspective, majority are under 50 deployments, with the median being about 38, right? And in terms of the number of services being run, the median number of services is 55, with almost 70% of customers having less than 100 services. So these are pretty useful global benchmarks here that give a sense for how enterprises are using Kubernetes. Now, obviously, how to deploy your applications on a Kubernetes cluster is heavily dependent on the workload and the application you're running. But to an extent, these Kubernetes adoption characteristics may indicate how far along you are in your Kubernetes usage journey and maturity. Furthermore, these benchmarks can also help guide one in thinking about their requirements for mature observability tooling and processes. So moving now more to the security side of things, we analyzed enterprises' attack surface and found that attack surface varies broadly across our customers. And knowing your cohort baseline can help contextualize the security posture and assess unusual threats. So we analyzed about 11,000 AWS accounts in Sumo Logic population of AWS customers and segmented them into about 3 cohorts. We analyzed the data and identified specific AWS services that were representative of the cohort characteristics. And then we looked at the volume, variety, and velocity. Volume here is defined as the number of resources of different AWS resources used here. Variety is the total unique number of AWS resources used, and velocity represents the total number of create, update, delete events we saw across all AWS accounts. And so then we plotted the relationship of these cohorts between the 3 V's or the 3 dimensions. So how do attack surfaces in Sumo Logic population compare? Each dimension is expected to correlate with breach risk. Simply put, the more resources you have, the more heterogeneous they are, and the more frequently they change, the greater your attack surface. The key finding here is when trying to compare your own attack surface, the additional insight you get from not just the global baseline, which is a green bubble here, but the cohort baseline would actually be more apt to compare yourself against. And what this really tells you here is your attack surface also increases the possibility of misconfigurations, alert fatigue, and other issues that could impair well-intentioned SecOps teams. And as a result, you also need to ensure that you have the right alerting tools set up. So let me bring in Manpreet here, who can talk a little bit more about how this data was prepared and how we use it within our own GIS CloudTrail for SecOps app.
Thanks, Shri. So the cohorts that Shri described just now are valuable to understand your stance as compared to your peers. And that is why we use it in the GIS CloudTrail for SecOps app. Just to give an overview, this app provides you with an idea of your security posture and enables you to compare your AWS CloudTrail events with your peers. This can help in detecting any unusual and potentially malicious activity in your account. To generate the cohorts, we run a clustering algorithm every day using the volume, variety, and velocity features of the customer's CloudTrail data over a period of 7 days. And baseline ranges are calculated for attack surface, MITRE attack tactics, and impacted resources for all the cohorts and presented to the customers through the app dashboards. So if a customer's CloudTrail event signals are not within the baseline range, then something unusual might be going down in the account. So as an example, if you see a high count of too many access denied CloudTrail events, that might be some unauthorized person trying to hack into your account. So you can set up alerts for these kinds of events such that whenever specific CloudTrail event in your account violate the benchmark range, you are notified right away. Also, as we also know that greater the attack surface area, greater is the breach risk. So if your attack surface is outside the benchmark range for your cohort, you might want to go over your AWS account resources and activities and look for ways to decrease the attack surface. Furthermore, we have the action plan dashboard in the app that can help by providing a prioritized plan to improve the security posture of your account. Over to you, Shri.
Great. Thanks, Manpreet. That's actually pretty interesting context here in terms of interpreting attack surface. So we also then started looking at guard duty data to identify the source of different threats to different AWS regions, right? And we plotted this on a map. The red pins here represent the AWS regions that have the top 25% in terms of share of threats received. The green pins here represent the bottom 25%, while the yellow represents the rest of the population. So you can see that some regions receive a higher than normal share of threats. Regions such as in Asia Pacific Southeast, US East, as well as Europe Central have a higher prevalence of threats. And if we kind of double click on just the US region alone, in terms of key foreign sources of threat, they are primarily Russia, India, and France. So let me kind of bring in Manpreet here again. We have the GIS Guard Duty app benchmark as well. So how would we kind of use this data during our day-to-day best practices?
Yeah. So another view of data presented in this slide is used in the GIS for Guardiot app, where the customers can compare their threat patterns with the global baseline. The global baseline is calculated by extracting information like threat name, country name, AWS region, etc. from the Guardiot findings over a period of time for all the customers. The baselines can be helpful in making the choice of AWS region where you serve your application and taking necessary actions to reduce the most prevalent threats in your account. This app works on the same principle as the CloudTrail app. That is, if your threat share is different as compared to other customers according to the baseline, then there might be something unusual in your account, like maybe some recent changes to the firewall rules has made your account more vulnerable. So you should follow this up with a review of the security posture of your account. Over to you, Shri.
Great. So, and then as part of a final analysis, we also looked at a CloudTrail and Guard Duty risk signals across the entire install base. So for CloudTrail, the global intelligence for AWS CloudTrail analyzes about 40 risk signals from over 11,000 AWS accounts, spanning key AWS services including EC2, S3, Identity Access Management, RDS, etc. And the prevalence here was measured as a share of total findings a particular signal represents in any given 24-hour period. And unsurprisingly, most of the top 10 AWS CloudTrail signals pertain to discovery tactics, which really represent the first set of actions taken by an attacker trying to compromise an AWS account. From the Guard Duty perspective, the global intelligence for Amazon Guard Duty analyzes over 55 threats from several hundred Amazon Guard Duty customers. And here again, the share of total findings for a particular signal is represented by in any given 24-hour period. And the signals are then aggregated into threat purposes used by AWS. And we see here that certain threat purposes such as root credential usage or cryptocurrency findings are relatively rare. So there are quite some differences between both CloudTrail as well as Guard Duty data here. Naturally so, since these data sources represent quite different things. Guard Duty is more about behavioral patterns, network and user activity, and is hence a little bit more real time and data that is kind of used in a more reactive fashion. Whereas CloudTrail is more of an audit and a look back on configuration changes, which could then be used to make proactive decisions for the future. So along those lines, let me kind of bring in David here. And so David, how should we be really looking at both these sets of data?
Thanks. So if we go to the next slide, we can see that we've got the, this is an example of what you'll actually see in the product. Again, this is one of the GIS apps available in Sumo Logic. Starting from the middle out, this is a very simple kind of you versus them plot for the different alert types, just as we saw before in the other example. And what this is showing you is simply of these different Guard Duty alerts, how prevalent are they in the global population versus in your account. And the principle here is that, of course, security practitioners are always sort of crunched for time, attention, and resources. And the hope is that this will kind of provide some additional context that might help users more efficiently and effectively allocate their scarce time and attention. So if there is an alert firing in AWS Guard Duty for your environment, but the global benchmark shows that it's highly prevalent across all customers all of the time, it might be the case that this is just sort of a kind of background noise alert that's very prone to false positives or something like this. Whereas an alert that is extremely rare, but you all of a sudden have a great deal of them and you did not before, that might warrant your immediate attention and that might be something you want to prioritize a little bit more highly. At the bottom, we're looking at sort of a mix of how your AWS Guard Duty threats kind of stack up severity-wise versus the global population. So you can see here that there's a mix of something like 65, 25, about 10 for low, medium, high severity. And you can see how that mixture sort of looks for you versus the other GuardDuty customers. If you have far more high severity threats as a percentage than the other, that might be something you want to look into. And this plot at the top is going to give you what we try to boil up into a kind of holistic risk or posture score based on your GuardDuty alerts. And this is taking into account the severity as well as some of this kind of like rarity, how common and prevalent are they, and trying to boil it down into a sort of compressed single number score that you can kind of look at and sort of examine on a day-to-day or week-over-week basis and see, is the proportion of threats, rare threats or high severity threats, sort of changing over time, and how can we sort of understand, is the AWS GuardDuty kind of threat mix overall showing us at an elevated or lesser risk than it was yesterday? And so this basically, of course, ultimately, there's no substitute for really digging in and pursuing and investigating these security threats. But the idea is that this kind of global context will sort of give you a head start and kind of more effective and efficient way to triage and prioritize and understand the context of your GuardDuty threat alerts and help you can more effectively maintain the security of your application. Back to you, Shri.
Great. Thank you very much, David. That was super helpful. So we kind of covered a lot of ground here in today's presentation. Just going to do a quick summary as we kind of come to the end. So one, we kind of analyzed and reviewed how reliable are different AWS services and learn how to architect and diagnose our apps around some of the AWS related root causes for outage. The other thing we did was we analyzed the relationship between an enterprise's attack surface and the use of AWS services, and then also discuss the implications of what it means from the perspective of what monitoring tools you would need. And finally, we analyzed security threats in AWS and discussed how this data could help us in prioritizing the right threats and avoid any kind of alert fatigue. So that brings us to the end of the presentation here. And thank you very much for tuning in.